Hi students, today I am going to discuss a topic, atomic collision. It is not in your academic syllabus when you are in class 12th, but it is in the syllabus of you can say entrance exam, NEET means or advance. Now the topic is atomic collision, so you can see this is the combination of two words, atoms and collisions. So atoms, it means something related to what? Bohr's theory, and collision, you know, Newton's mechanics. So it is the combination of two topics, the Bohr's theory and then collisions. Okay, so now I am going to start this topic. In this topic, mainly the question comes like this, that there is a hydrogen atom. It is hydrogen atom which is at rest and at ground state. It is at ground state. Fine. Now, here it is a neutron. This is a neutron. Okay, and it is moving with, let speed v, and this neutron collides this hydrogen atom. We have to find out that whether the collision is elastic or inelastic. This is the only concept which we are going to study in this topic. Fine. So as you know, in mechanics, if collision is elastic, then there will be no loss of energy takes place. Okay, so initial kinetic energy and final kinetic energy remains same. But if the collision is inelastic, then the loss of kinetic energy takes place. So if the collision between neutron and hydrogen atom becomes inelastic, then some loss of energy takes place, and that loss of energy is absorbed by electron in this hydrogen atom and helps that electron to jump in excited state. It means if electron jumps to excited state, it means the collision is what? Inelastic. So now we are going to find out the condition when the collision is inelastic. Okay, so start with two assumptions. The first assumption, let mass of hydrogen atom is approximately mass of what? Neutron, which is almost equal. And the second, collision is head-on. Collision is head-on. It means centers. The motion, the direction of motion is along the line joining the center of neutron and hydrogen atom. So collision is head-on. These are the two assumptions. Now we start simple, the concept of mechanics. This is the neutron having mass m, moving with speed v, and in the same line there is a hydrogen atom having same mass and it is at rest. Now, after collision, suppose this neutron, it is moving with v1, and similarly this hydrogen atom, it moves with speed v2. Means you can say v1 and v2 are the speed of neutron and hydrogen atom after collision. So you know, in every type of collision, momentum is always conserved. So you can say initial momentum is equal to final momentum. Now initial momentum, you can see this is m into v, the momentum possessed by what? Neutron. And in final momentum, it is mv1 plus mv2. So we can say the first equation we get, that is v is equal to v1 plus v2. This is the first equation. Now in second step, initial kinetic energy is equal to final kinetic energy if collision is elastic. But if collision is inelastic, there would be some loss of energy takes place. Let that energy is what? Delta E. Here this delta E is loss of energy. Loss of energy. It means here we are assuming that collision is what? Inelastic. Fine. Okay. Now initial kinetic energy. So this is half mv square. Final kinetic energy is half m v1 square plus half m v2 square plus what? Delta E. Now when we simplify, we can get it multiplied by 2 by m. So here it is v square, here it is v1 square, v2 square, and it is 2 delta E upon m. This is the equation number 2. Okay, the simple 2 equation. Now with the help of these equation, we are going to find out the relation between delta E and the kinetic energy of this striking neutron. See, here it is v, here it is v square. So what we do is square the equation 1. So when we square the equation 1, we get v square is equal to v1 square plus v2 square plus what? 2v1 v2. v1 square plus v2 square plus 2v1 v2, and here it is v1 square plus v2 square plus 2 delta E by m. Now equate 2 and 3. So from 2 and 3 we can say that here v square, when we equate v square plus v2 square is what? Cancel. So we get 2v1 v2 is equal to 2 delta E upon m. Fine. Now we are going to use this value in a mathematical identity. You know, in algebra, a minus b whole square is a plus b whole square minus 4ab. The same result we are going to use, that is v1 minus v2 whole square is equal to what? v1 plus v2 whole square minus 4 v1 v2. Now see, v1 plus v2 is what? V. So in the place of this we can write v, and in the place of v1 v2 we can put this value. So the result comes like this, that v1 minus v2 whole square is equal to v square minus 4 v1 v2. In the place of v1 plus v2 I write this v square. Now 2 v1 v2 is 2 delta E by m. So you can say it is 4 delta E by m. 2 v1 v2, here it is 4 v1 v2. Now since v1 minus v2 whole square, it should be greater or equal to what? 0. It is a square quantity, it has to be positive. So either it is 0 or positive, greater or equal to 0. Therefore you can say v square is greater or equal to what? 4 delta E by m. So here you can say mv square by 4 is greater or equal to what? Delta E. Or you can say half of what? Half mv square, and half mv square is what? Kinetic energy. Half mv square is k, and this is 1 by 2, so it becomes 4, is greater than what? Delta E. And this is the condition. In this explanation we assume that the collision is what? Inelastic. So this is the condition of what? Inelastic collision in atomic collision. So you can write in this way also, delta E is less or equal to kinetic energy of neutron, or you can say striking of kinetic energy of neutron divided by 2, half of the kinetic energy of neutron. So if this condition satisfied, then collision is what? Inelastic. Delta E is the loss of energy, and this energy is nothing but which is used to jump electron from ground state to excited state. Okay, so remember this result for the question based on atomic collision, provided collision is between neutron and hydrogen atom. So this is the condition of what? Inelastic collision. It is condition of inelastic collision. Now, which I explained, that is collision between neutron and hydrogen. Now, with the help of one example, it would be much clearer. In this problem, here it is a neutron moving with same speed, you can say v, and here it is a hydrogen atom at rest, ground state. You have to find out the minimum kinetic energy of neutron so that collision becomes inelastic. Okay, so as you know, I told you that for inelastic collision, it could be perfect inelastic also. So for inelastic collision, I told you that delta E is less or equal to half of what? Kinetic energy. So you can say kinetic energy of neutron, it should be greater or equal to what? 2 delta E. 2 delta E. Now K is greater or equal to, so therefore K minimum is equal to 2 delta E, and obviously in that case delta E should be also minimum, and delta E is the energy absorbed by electron which transit it from ground state to excited state. So since it is minimum, so the minimum delta E for hydrogen atom, and as you know, at ground state the energy of this atom is what? Minus 13.6 electron volt, and when it comes to excited state, then n becomes to orbit number, you can say, and then energy becomes what? Minus 3.4 electron volt. I think this result, these result 13.6 electron volt and 3.4, it comes with the formula what? Energy of orbiting electron in nth orbit for hydrogen atom minus 13.6 upon n square. So putting n1 13.6, putting n is equal to 2, it is 3.4. So if I say delta E, it means the energy required to jump from n is equal to 1 to n is equal to 2, or you can say ground state to first excited state. Delta E is equal to what? It is minus 3.4 E2 minus E1. So minus of minus 13.6, you can say it is 10.2 electron volt. Now, here the kinetic energy, the minimum kinetic energy required is what? 2 delta E, 2 into 10.2, that is 20.4 electron volt. So in MCQs, if the options is in electron volt, this is the answer. If it is in joule, multiplied by with 1.6 into 10 to the power minus 19, it becomes joule. If in question it says find minimum speed, so equate this kinetic energy is equal to half mv square, and m is the mass of hydrogen atom, which is approximately 1.67 into 10 to the power minus 27 kg. So you may find out the minimum kinetic energy in electron volt, joule, you will find out the speed. So with the help of this concept that kinetic energy of incident neutron should be greater than 2 delta E, where delta E is the energy required by electron to jump from ground state to excited state, you may solve all the problems related to atomic collision. Okay, now I hope you understand the topic of this atomic collision. If you have any doubt, you may ask me. Thank you.